So this summer, I learned how to kill a tree. And you might be wondering, did the summation of my environmental studies degree actually result in this? And yes, it did. So it turns out dead trees are really important to forest systems. And one really great tree killer is the bark or ambrosia beetle, this tiny little black dot. You might recognize some cool patterns in wood that make them through chewing through the wood. They introduce this fungi to the tree, and ambrosia beetles will eat the fungi, whereas bark beetles will eat the wood. So I wanted to know more about them, and the first thing you might hear about them is their notoriety in the lumber industry. So they also are known for their outbreaks in forests near us. But as it turns out, only a few of these species have evolved to attack healthy trees, and most are attracted to stress and dying trees and are part of normal, healthy, functioning ecosystems. They assist in nitrogen cycles, carbon fluxes, and they facilitate structural diversity in forests, as well as creating habitat and food sources, and they could even increase stream flow. So my question was, how do they relate to dead and stressed trees, and how can their ecology be used in forest management practices? So to help me find this out, I surveyed each of the trees for the presence of beetles by looking for pitch clumps, which are released by trees when they're attacked by bark beetles. I looked for frass, which is like tiny wood shavings, and I also looked for their exit holes. But why talk about this? So Washington State has a history of logging. This resulted in clear cuts that grow into young homogeneous forests, and it will take them hundreds of years to become old growth forests. A key part of old growth forests is a standing dead tree, also known as a stag. They create habitat for insects, woodpeckers, and nesting mammals and birds. In addition, bark beetles are great at creating snags because they attack weak dominant trees that let light into the understory when they die. So to help create more snags, the Great Peninsula Conservancy did this technique called tree girdling. Tree girdling is when you make two parallel cuts around the base of a tree to stop the flow of nutrients and kill it standing up. Our job this summer was to measure the girdles and see what factors could help predict tree death. We measured 150 trees this summer in 8 different sites along the Great Peninsula or Greater Bremerton area. We also took measurements such as species status and the species status of the tree, as well as the girdle condition. This is an example of a peeled girdle, and here's my co-intern Maya, who was very helpful this summer. So we found that over time since girdle, there's an increase of dead trees as well as beetle presence. We also found that red alder and Douglas fir are more susceptible to both bark and ambrosia beetle attacks and to the girdle wound itself, as indicated in these graphs. So this is important because red alder and Douglas fir were the most abundant tree species in the forest that we looked at. We also found that bigger, older trees are more susceptible to tree girdles, as indicated in this red line. Bigger, older trees, when they die, make more resources than smaller trees, more habitat, and help more light come through the understory to help it develop. So in conclusion, we only found 2 statistically significant variables that predict tree death, species, and time, but adding my beetle data gave it a much richer context. I'm suggesting an emphasis on bark and ambrosia beetle dynamics in girdling forest management, in short, because they are very knowledgeable at tree killing and decomposition. Working in synergy with established forest systems can also save money, time, and other resources, as well as resulting in more holistic, interesting, and useful information. To conclude my presentation, I want to draw attention to the genocide in Palestine. As we finish our degrees this quarter, I want to honor the tens of thousands of college students who have been killed by the Israeli military, and to the survivors who can't finish their degrees because their universities are being systematically destroyed. Thank you.
Question for Abigail.
Yes.
About essentially why those beetles have evolved to target healthy trees.
Thank you for the question. So the question was, did I come across any information about why some beetles attack healthy trees versus not? So bark and ambrosia beetles are actually like a lot of them will work with a lot of different trees, and sometimes that means like they can, I guess, get better at killing healthier and healthier trees. So it's probably a slow process. Um, it could also be because of invasion or they're brought over by lumber, but I didn't really focus on that question. But thank you.